Any questions on anything we've done so far? Okay. What we're doing today is we're finishing up 2-3. So we will finish 2-3 up today. What we have left is actually not that bad. It's just looking at multiple angles and then doing some that don't factor. Now, when we look at this first one here, we have 2 cosine of 3t minus 1. Equals 0. And for these multiple angles or half angles, we're going to solve them exactly like we would any other function, any other cosine, sine, any tangent trigonometric function, where we just have one trigonometric function in the equation. And the first thing we can do is add 1 to both sides. And when we add 1 to both sides, we're saying that 2 cosine of 3t is equal to 1. Well, we still need to get cosine by itself, so the next thing we can do is divide both sides by 2. Which is going to tell us that cosine of 3t is equal to 1/2. There it is. Because everything we've done up to this point has been the exact same as what we've done before. There's been no change. And again, finding the value for this here isn't going to be any different. Except for now, instead of just saying t or x or theta, we have 3t. So we're trying to see what angle cosine of 3t would be for it to equal 1/2. And again, we can use the unit circle, seeing where cosine is 1/2. And one of the spots where it's 1/2 is pi over 3. And if we keep going around the unit circle, we'll see that it's also at 5 pi over 3. Questions on this so far? And again, when we had just t, we would also, since this is not restricted from 0 to 2 pi, we're going to also add 2 pi into it. Any questions on any of this here so far? And really at this point, this hasn't been any different than anything we've done. Would y'all agree with that? It's the exact same thing. Now, is t our angle by itself? No. So what would we need to do to get it by itself? I would need to divide by 3, yes? Which means we're actually going to divide everything by 3. So this will give us t, our angle by itself. But now we're going to need to divide pi over 3 by 3, which would give us pi over 9 plus 2 pi n over 3. So there's one of our sets of angles. We would do the same thing with the other side. Here we would have 5 pi over 9 plus 2 pi n over 3. And that would be it. Questions on any of this here? Let's look at the next one. 2 sine of 2t minus square root of 3 equals 0. So again, we're going to treat this exactly as we did the previous one. Well, first thing we can do is get sine by itself. So we can add the square root of 3 to both sides, telling us that 2 sine of 2t is equal to square root of 3. Then our next step is going to be to divide both sides by 2. Telling us that sine of 2t is equal to the square root of 3 over 2. Now sine of 2t between 0 and 360 is going to have two different values, because sine is square root 3 over 2 at pi over 3 and at 2 pi over 3. Now again, because we are not restricted between 0 and 360, we still have to add the 2 pi in. Last but not least, we have to get t by itself, so we're going to divide everything by 2. That will give us t by itself. Pi over 3 divided by 2 is going to be pi over 6 plus, well, this time 2 pi in is actually going to be a little bit nicer, because 2 divided by 2 is 1, just telling us that this is pi in. We can do the same thing with the other side. 2t divided by 2 is t. 2 pi over 3 divided by 2 is going to be pi over 3. I mean, it would be 2 pi over 6, but 2 and 6 would simplify to pi over 3, plus pi in. And we get these two here. Now, the nice thing, especially with dividing by 2 or dividing the pi over 3 here, or 2 pi over 3, the yellow calculator, the 30xs, will do those nicely. We won't have to approximate pi. We don't have to do anything with it. We can just do pi over 3 divided by 2, or pi over 3 divided by 3, and it'll give it to us. And that's it. That's all we have to do. Questions on any of this here? Let's look at the next one here, because we'll probably do this one here and move on, because this here isn't any different. It's not any different than what we just did. Because we only have one here, we can get it by itself. So we can subtract 3 from both sides, telling us that 3 tangent of x over 2 is equal to negative 3. The next thing we can do is divide both sides by 3, telling us that tangent of x over 2 is negative 1. So really, again, even though this time we have a half angle, it hasn't changed the process. And at this point here, we can again look at the unit circle to see where tangent's negative 1. Now again, on the unit circle, we aren't given tangent directly, but we did fill in where tangent's negative, and tangent's negative in the second and fourth quadrant. And since we're looking for 1, we're looking where sine and cosine are the same, which is going to be 3 pi over 4. And going the other way around is 7 pi over 4. And again, they didn't restrict us between 0 and 2 pi. So this time we're going to add what to both sides? Pi in. And the reason we're adding pi in is because we're dealing with tangent, and tangent's period is only pi units. So we have pi in. Anybody have a guess at what we're going to do next? Multiply by 2. We divided by 2 last time because, again, we needed to get x, or the angle, by itself. So this time we're going to multiply by 2. Because here the 2 and 2 would cancel, telling us x is by itself. Here we can multiply through by 2. So we do 2 times 3 pi over 4, which is going to give us 3 pi over 2. 2 times pi in is going to be plus 2 pi in. We'll do the same thing to the other side, or to the other set. X over 2 times 2 is just going to be x. 7 pi over 4 times 2 is going to be 7 pi over 2 plus 2 pi n. And that's it. That's all we have to do with these here. Any questions on any of these here? We feel pretty comfortable with half angle, double angles. We're going to look at 2 more and then we'll be done for the day, and you'll have the rest of the time to work on the assignment from chapter 2. Now when we look at this here, we have secant squared minus 2 tangent of x is equal to 4. Well, 1, we need it equal to 0, and 2, we need it to be all the same trigonometric function. So one of the first things we can do is subtract 4 from both sides, which then tells us that secant squared of x minus 2 tangent of x minus 4 is equal to 0. Now we also know that tangent squared of x plus 1 is equal to secant squared of x. And the reason this is helpful is that we can take secant squared of x, which we do have in the equation, and replace it with tangent squared of x plus 1. Any questions on this so far? Now we can combine like terms. Tangent squared of x minus 2 tangent of x minus 3 is equal to 0. Now we can go on and factor and then solve. So when we factor this here, we look for greatest common factors first. And really, if there's a number in common with all 3 terms, and if we're just solving, we're not just factoring it, we could divide that number out. It's going to give us the exact same answers. But here, there is no greatest common factor. There's no number that's in common. So we'll find the signs. Since the third term is negative, our signs are opposite. If the third term was positive, the signs would be the same and match the sign of the middle term. Then we need to find the factors of the first and third term. Factors of tangent squared of x is just going to be tangent of x and tangent of x. That's the only way we can get tangent squared is if we multiply tangent by tangent. Now, luckily for us, also the factors of 3 are just 1 and 3. We only have 1 set. Now we need to determine which one's going to be positive and which one's going to be negative. Well, our middle term is positive or negative. Negative, yes? So we'd want the bigger multiplication across to be negative. So we would make the 3 negative because the number in front of tangent's 1. So we're looking at really 1 times 3 and 1 times 1. So we would want 3 minus 1. And we can always check to make sure we do have it right. Tangent times negative 3 is negative 3 tangent. 1 times tangent is going to be plus tangent, which does give us negative 2 tangent, like we wanted. And again, like we've done before, we're going to say that tangent of x plus 1 is equal to 0 because our zero product property states that any 2 things multiplied together to equal 0, one of them must be 0. So looking at this first one here, tangent of x minus or plus 1 equals 0. We can subtract 1 from both sides. telling us that tangent of x is equal to -1, yes? Well, we've already worked with this one here, because this one is nice for us. We do have it on the unit circle, which will have two different values. And one of them is going to be 3 pi over 4. And the other is 7 pi over 4. And because we are not restricted between 0 and 2 pi, we add the pi in because that is the period for which tangent repeats itself. So we have these two here. Now we could have used arctangent, tangent inverse of -1, and tangent inverse of -1 is actually not going to give us 3 pi over 4 or 7 pi over 4. It'd give us negative pi over 4, but it's still the same thing as 7 pi over 4. And we could have done this with the previous one. Aren't these pi units apart? Because they're on opposite sides. So really we could say this is what? X is equal to 3 pi over 4 plus pi n. We can write it as a single statement because it will hit the other two. Because 3 pi over 4 plus pi, or 1, is going to be 7 pi over 4. So we can write it as a single statement. Questions on this here? All right, let's look at the other one. Well, the first thing we can do is add 3 to both sides, which tells us tangent of x is equal to 3. Is that on the unit circle? No. 3 is not on the unit circle, but can tangent have a value of 3? Yes. It's one of tangent, cotangent, secant, and cosecant are the 4 that can have a value greater than 1. They're the only 4. If sine or cosine has a value greater than 1, we're trying to find sine of an angle that's equal to 3. It doesn't work. But here it does. But this time we're going to have to use our inverse functions. We're going to have to apply arctangent to both sides. So I'll write this out below. So what we're going to take is arctangent or tangent inverse of both sides, which will tell us that we have arctangent of tangent of x is equal to arctangent of 3. These here are simplified, just telling us x is equal to arctangent of 3. Now it's not going to be a nice value. Most likely it's going to be a ugly decimal. So we'll leave it as this here. Arctangent of 3 plus pi n. Questions on this here? Not too bad. Because, I mean, we could figure out what arctangent of 3 is. Second tangent inverse of 3 is this decimal here, divided by pi. Even pulling pi out, it's still not a nice number. I can try to see if the calculator will, nope, it won't put it back into a fraction. It's not a nice angle any way we look at it. So any other questions on this here? So we'll look at this one here. Yep. And this here, I have a feeling is probably going to be one of the last ones we look at. And then we'll move on. we'll look at two more. We'll look at this one and one more. Now this one here, the first thing we can do is factor it. Now there's not a greatest common factor between these three terms, so you can't pull anything out. So the first thing we can look at is signs. Well, since the third term is negative, our signs are still opposite. That means we need to look at the factors of the first and third term now. Well, for tangent squared of x, well, one of the things we know for sure is we're going to have tangent and tangent. That's just a given. But now we're looking at the factors of 4. We have 1 and 4 or 2 and 2. And we also have the factors of 6, which is 1 and 6 or 2 and 3. And we're trying to see which one of these will work. Now we said there wasn't any greatest common factor to begin with, yes? So I'm going to write this out so that we can see it. But one of the set of factors that we know we don't have to check is 2 and 2. 2 and 2 won't work. And I'm going to fill this in kind of underneath. Because if we said 2 and 2, here and here, and I'll pick 1 and 6. These two here have a greatest common factor of 2, yes? If one of the parentheses has it, that means there had to be 1 to begin with. Well, there's not, so we can't do that. So I could do, say, 6 and 1, but I just created a greatest common factor on the other side, yes? Okay, those don't work with 2 and 2. Our other one is 2 and 3. Well, the first two have a greatest common factor of 2, yes? If I flip the 2 and 3, we still have a greatest common factor of 2. So kind of looking at that and seeing that tells me 2 and 2 is not going to work because there would be a greatest common factor no matter how we set it up. Now, if you start going through these and keep seeing greatest common factors no matter how you set them up, look back at the original problem. There might be a greatest common factor we missed. So that leaves us with 1 and 4. Okay? I'm just going to throw the 4 in. There's a good chance we'll probably have to rearrange it or flip something, but I'm going to throw the 4 and 1 in. Now we're either looking at 1 and 6 or 2 and 3. Which one do you guys want to try first? We can try 2 and 3. But as we just said, we can't put the 4 and 2 together. Because that would give us a greatest common factor of 2. Those don't work. And we couldn't put the 4 and 6 together. Now if we check this here, 4 tangent times negative 2 is negative 8 tangent. 3 times tangent is going to be positive 3 tangent, which will give us negative 5 tangent of x. Is that the number we wanted? Well, no. Well, kind of, isn't it? Because we wanted 5, but we wanted it to be positive, not negative. And one of the nice things, whenever we get the correct number, but wrong sign, is I just need to flip the signs. If you get the correct middle term, but wrong sign, flip the signs and you have it right. Because now 4 times 2 is going to make this positive 8 tangent of x. That's not going to be positive 3 tangent, it's going to be negative. This makes up a positive 5 tangent. Now we can set these equal to 0 and solve. So for the first one here, we can add 3 to both sides, telling us that 4 tangent of x is equal to 3. And then we can divide by 4, telling us tangent of x is equal to 3/4. Well, 3/4 is not on the unit circle because for tangent, the main ones that we have are square root 3/3, 1 and the square root of 3. So here we're going to have to use our tangent inverse or arctangent. So we have that x is equal to arctangent of 3/4 plus r so we have this here. Now this will give us one specific value. And we'll deal with that here in a minute. Any questions on this so far? Now we can look at the other one. We can subtract 2 from both sides, which tells us tangent of x is equal to -2. And luckily for us, tangent can have the value of -2. Any questions on this so far? Now this one here was restricted between 0 and 2 pi, yes? So we have two values at work, these two here. Now I'm going to go on and graph it. 4 tan 5 minus 6. 4. So we have all this here. Now again, just to give us an idea where 2 pi is, and it's way up high apparently. Okay. So we're way over here. But how many times does it cross between 0 and 2 pi? 4 times, yes? How many answers did we get? 2. And we could see that second calculate value, tangent inverse of -2. We have the value there, yes? But again, we're talking about it being positive, well, 0 and pi. So, -6. So what we could have done, is done tangent inverse of -2 plus pi, which will give us our value here, yes? So it gives us one between 0 and 2 pi. We had to adjust that. Now say I do this, but instead of adding pi, we add 2 pi. Well, that's our second value, yes? Because again, between 0 and 2 pi, tangent has two values. So for this one here, we really have to add pi. And 2 pi, which means for this one over here, we're going to have to add pi. Well, back up. We're just going to have to add pi to it. Now the reason I'm not doing pi and 2 pi is mainly because arctangent of 3/4 is actually between 0 and 2 pi. And I can show you that here. So I can calculate value, tangent inverse of 3/4 is actually between 0 and 2 pi. So it works. And the other value would be adding pi to it. Questions on this here? So this one here is a little funky because it does add the 0 to 2 pi. Because if it didn't have that, we would have just added pi into both and we were done. Here we had to actually figure out what the four angles were. Questions on any of this here? This here is the last one we're going to do. This is the last problem we're going to work with, and it's actually not that bad. Now, we've dealt with the quadratic formula before. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And again, when we talked about these here, and when we talked about quadratic formula, we said it was nice because this worked with any quadratic. And it's true. It doesn't matter if we have trigonometric functions, it still works. But instead of having x, we're going to have sine of x. Now the values for a, b, and c still hold true. A is going to be the number in front of sine squared, b is going to be the number in front of sine to the first power, and c is our constant term. So we'll have negative b is going to be, or negative b is going to be negative 3, plus or minus the square root of b squared. Negative 3 squared minus 4. Well, the number in front of sine squared, our value of a is 1. And c is negative 2, all over 2 times 1. Now at this point here, we can start simplifying our expression. Well, negative 3 is 3. 2 times 1 is 2. Now again, I wouldn't completely plug everything inside that with the radical and everything inside it into the calculator at this point. I would just plug what's inside. So we would have negative 3 squared minus 4 times 1 times negative 2. And we get 17. So if we did this on the graphing calculator, it would have given us a decimal answer. And if we did this in the yellow calculator, it would have worked out fine and just told us it was the square root of 17. Any questions on this here? Any questions on anything we've done so far? Okay. Well, with the plus or minus, it's really telling us that sine of x is equal to 3 plus the square root of 17 over 2. And that sine of x is also equal to 3 minus the square root of 17 over 2. Would it be safe to assume this is not going to be on the unit circle? Yeah. So we'll have to use our inverse functions. So we'll apply sine inverse to both sides, telling us that sine inverse will be 3 plus the square root of 17 over 2. And here we'll have x is equal to sine inverse of 3 minus the square root of 17 over 2. Any questions on this so far? Now, unfortunately for these here, we're going to need to approximate the answer, approximate what theta is going to be, our angle is going to be. What's nice for us is we can do these in the graphing calculator. So we can say second sine inverse alpha y equals, enter 3 plus square root of 17 over 2. So this is the first one we had. Make sure I type that in right. That's having a... Oh. So this one here doesn't work because the value is too big. This 3 plus the square root of 17 over 2 is going to be a number bigger than 1. So this one doesn't work. Okay. We can change it from plus to minus because the other one was 3 minus the square root of 17 over 2. And we do have a value. Yes? So we have an angle which is negative 0.5962 going on. Now, that is nice to know, but if we look at this here, we want it on the interval from 0 to 2 pi, yes? Now, negative 0.5 going on and on and on is not between 0 and 2 pi. Because 0 and 2 pi, we're talking about positive numbers, yes? Now, going straight down, clockwise is actually negative pi over 2, yes? So just for a reference point, negative pi divided by 2 as a decimal is negative 1.5707 going on and on and on, yes? So what that's really telling us is that it's in the fourth quadrant. Not too bad. I didn't actually need to do that calculation because sine inverse angles are restricted between negative pi over 2 and pi over 2. So it's restricted to the first and fourth quadrant. So if it's negative, it has to be in the fourth. If it's positive, it has to be in the first. If we do sine inverse, which all that means for us, if I want to find that angle, well, we're down here because this is the angle they gave us. If I want the positive version, I'll pick this color. We're just going this way here, and that was a bad choice of color. Which is just the other part of the circle, yes? The whole circle is 2 pi. So if I add it to 2 pi, or essentially take that number away from 2 pi, we'll get the positive value of the angle. So what we can say is 2 pi plus this here. We'll go out 3 decimal places. We can go out 4. 3 or 4 is fine. Now, it might seem weird that we're adding it, not subtracting it. But the value of our angle that's given is negative, yes? So if I add it with the negative value, I'm actually subtracting it from it. So one of the values of the angle is 5.6869. Different color. That's one of our values down here. Where is sine also negative? Down here, yes? Because the sine's values, they do repeat, positive, negative. So the other one's going to be over here. Because again, this angle that they gave us, 0.5962, here is really 0.5962. Because we can have that with it still being a negative value for sine. So this time, we need to add it to 2 pi, yes? But the value of it's still negative. Or we can just say pi plus this on the calculator. You can manipulate this a little bit. Get rid of that. But we said the value of this was what? Negative, yes? So how could I make it positive? With another negative, because we know sine of that's going to be negative. The negative and negative would make a positive. Now, even if you said plus, we know that this angle should be greater than pi, yes? What's the value of pi? 3.14, yes? So if I hit enter and I got a value smaller than it, I know I would need to change the sign. But here, we do get a value bigger than 3.14, so 3.7379. And that's it. Are the values for this here between 0 and 2 pi? Any questions over any of this here? Now again, the reason, or kind of the way that I got these is just knowing that sine is negative in the second, or the third and fourth. If it had been positive value, it would have been the first and second. If this was cosine, cosine is negative in the fourth, let's see here. Sorry, it's negative in the second and third. So we would have dealt, instead of with 2 pi and pi, dealt with pi, subtracting it and adding it to get those values. But I'm not going to bore you with any more of this here. And we're going to be finished with this part. And I don't think y'all want to spend another day on this section.